Antarctica is a vast, frozen continent where some of Earth's most extreme conditions can be found. Interestingly, despite being almost entirely covered in ice, Antarctica is actually the largest desert on the planet. Deserts are defined as places where precipitation, whether in a form of rain, snow, or fog, is less than 250 millimeters annually, and there are areas in Antarctica where it hasn't rained for at least 2 million years. It's also where the coldest temperature ever recorded on Earth was observed, a bone-chilling minus 89.2 degrees Celsius. But hold on, the answer isn't as simple as that. While minus 89.2 degrees Celsius is incredibly cold, Antarctica isn't the coldest place in the universe. It's just the coldest on Earth. Remember, Earth is just one small part of the vast universe, and humans aren't the center of it. If we look beyond our planet, we can find places even colder. Let's take a quick tour of the solar system to find these icy locations. Imagine you're a fan of summer, especially the summer on Mars. At the equator of Mars, during its summer, temperatures can reach a pleasant 20 degrees Celsius. However, don't forget your jacket, because at night, the temperature can plummet to minus 73 degrees Celsius. Mars offers something for everyone, with both warm and freezing temperatures in a single day. If you're really into the cold, though, you'll want to head to the outer planets. Take Neptune, for example, where temperatures can drop below minus 200 degrees Celsius. That's cold enough to freeze almost anything you can think of. Now, you might be wondering if there is a limit to how cold things can get. The answer is yes. There is a lowest possible temperature known as absolute zero, which is about minus 273.15 degrees Celsius. It's the point at which particles can stop moving completely, and nothing can get colder than this. This temperature is important in science, and it's measured using the Kelvin scale, which sets zero as absolute zero. So, while Antarctica holds the record for the coldest temperature on Earth, the universe offers even more extreme chills if you're willing to travel far enough. Before we dive into why absolute zero exists, it's important to understand what temperature really represents. The temperature of a gas, solid, or liquid can be interpreted as the kinetic energy of its particles. Essentially, temperature tells us how fast the molecules in a material are moving and colliding with each other. However, there is an interesting detail here. You'll never hear about measuring the temperature of a single particle. Temperature is always a measure of the average kinetic energy of all the particles in a substance. This concept can lead to some puzzling situations. For example, if we have air at 20 degrees Celsius and calculate the average kinetic energy of its particles, we find that they're moving at about 500 meters per second, faster than a speeding bullet. But if the particles are moving that fast, why don't we feel a constant, intense wind? The reason is that temperature is an average. Each molecule or particle is moving in a different direction, and our movements cancel each other out, leaving the air as a whole essentially still. So while individual particles are zipping around rapidly, we don't feel any movement because the net effect is negligible. Now, as we cool the air, say down to 0 degrees Celsius, the molecules start moving more slowly. The lower the temperature, the slower the movement of the molecules. This relationship is direct. Less temperature equals less molecular motion. Think of lowering the temperature as slowing down the particles, almost like applying brakes to them. If you could completely stop their motion, you'd reach absolute zero, the lowest possible temperature where all kinetic energy is removed from the particles, and they are completely at rest. But here's the catch. Reaching absolute zero is impossible. This impossibility is due to a well-known principle in physics called the uncertainty principle, which sets a minimal limit on the speed of particles, preventing them from being completely still. No matter how hard you try, absolute zero remains unattainable. However, that doesn't mean we can get very close to it. In fact, the coldest known place in nature is the Boomerang Nebula. located about 5,000 light years from Earth. Its temperature is just 1 Kelvin, which is only 1 degree Celsius above absolute zero. While we can't reach absolute zero, the universe still offers places that come incredibly close to this extreme limit. Here's an interesting twist. The coldest place in the universe isn't in some distant galaxy or faraway nebula. It's actually right here on Earth, in Finland. In the year 2000, scientists working at the Helsinki University of Technology managed to reach an astonishingly low temperature of just 100 picokelvin. That's 100 trillions of a Kelvin. A temperature so close to absolute zero that it's almost unimaginable. But why go through all the effort and expense to reach such frigid conditions? The answer lies in the pursuit of knowledge, and it's one that won the Nobel Prize in Physics in 2001. These scientists were awarded the prize for the groundbreaking work in achieving such low temperatures and for discovering a new state of matter called the Bose-Einstein condensate. You've probably learned that matter exists in 3 states: solid, liquid, and gas. However, this is only partially true. There are actually at least 5 states of matter, and the Bose-Einstein condensate is one of the most fascinating, predicted theoretically by Bose and Einstein. This state of matter is remarkable because quantum effects, which are usually only observable at microscopic scales, begin to dominate even at the macroscopic level. When matter reaches this condensate state, all the atoms act as if they are one single entity, behaving like a giant atom. Under these extreme conditions, scientists can observe quantum phenomena that are usually hidden from view. Achieving these ultra-low temperatures also allows researchers to study other strange states of matter, such as superfluids. For instance, if you cool helium down around 2 Kelvin or minus 271 degrees Celsius, it transforms into a bizarre liquid that can flow through tiny cracks and even climb up the sides of a container as if gravity doesn't apply. So while the coldest natural place might be the Boomerang Nebula, the coldest temperature ever achieved in the universe is right here on Earth. And this isn't just a random occurrence. Earth is unique in the cosmos for having a climate that supports life as we know it. It's a reminder of just how extraordinary our planet is. Thank you very much, and I see you next time.